All right, today is June 10th, 2022, and the polyphonic module is complete. Still a few things to touch up a little bit to finesse, but basically it's done. And some of you out there on Synth DIY have asked about how it works and stuff, and it's how does it work? Good question. It's amazing that it works at all, but there's so much to it, but people wanted an explanation, so here we go. So the action starts with this circuit board right here. This is I call this the voice audio power board because it controls the power supply, it generates the waves, and then it mixes things on the way back out. So what we have here is two chips right here, and these are the 40106 hex Schmidt trigger chips. Each one of those inverters forms an oscillator, 12 of them, and they are tuned by these trimmers right here, these blue ones. And then all of those pitches from the master oscillators here are divided down by this row of 12 divider chips here, right? I'm trying to do this while looking at the camera, not looking at the board. And all of those individual notes are sent to this header on the back. So all the pitches that you play are coming out here. Now the other chips on here are there's two op amps. One is the oscillator for the vibrato, and the other is an audio mixer and tone control here. Also a voltage regulator. And I'm not sure if I like the decision I made to put optocouplers in for a CV input on the tone and the master tune, but there's two optocouplers. Since it works by resistance, I thought, well, why not? Let's just put a couple optocouplers against there, in the circuit, and then we can just plug in a jack and vary the tone and the tuning a little bit. I mean, it does do it, but I think maybe later on it'll just be a pedal CV input. I think that would work better. And then there's three RCA, well, three on this one. We actually only need two. There's actually a space for four individual RCA jacks here for where the audio comes in, gets mixed, and then comes out to the front panel. And the front panel controls plug in here. The Eurorack supply plugs on here. So you got the notes being generated here. And remember that these are 12 free running oscillators. They're not tied together in any way. So there's no crystal in this thing, with a divide down chip creating the individual pitches. Each note of the scale, C, C sharp, D, D sharp, and so on, is individually tuned and has nothing to do with the others. They're completely free running, which is kind of like herding cats, but there you go. So from here, the signals go into one of these, and there's two of these in every module. This is the keying module, and this is good old-fashioned organ diode keying circuitry made into service mount. So each individual note, and there's 32 notes on a board here, each individual note has its own keying circuit with 5 diodes, a couple of resistors, 2 capacitors, I think that's it, and one field effect transistor. So the pitch, the oscillators are coming in here, and then signals from the keying circuit, which are behind it, are coming into this header, and all those circuits are combined and go to an audio output here, which then plugs onto this. Okay, so you have this, and it plugs on the back there. This is the key to the whole thing, being able to make it work, is squeezing this down into a surface mount assembly. And actually, I'll tell you, we bought a Behringer VC340, which is fully polyphonic, a keyboard, little keyboard. It's the vocoder, copy of the Roland vocoder, to see how they did it. And we saw that Behringer did a divide down assembly with surface mount, and I figured if they could do it, we can do it. And hey, we did it. So there it is. So then you also have some plugs on here for controls, positive, negative, and then gate. You call it gate trig. I call it organ and piano, whether the notes will sustain when you hold the note down or whether they will immediately die off, like a percussion. So I call it organ piano, but that's what those plugs are. So behind these and behind this, you have one of these boards. I call this the level shift board, and what it does is it takes the circuits from this board, sorry for all the noise outside, this is one of Roman Silva's Midi boards, and it plugs on here, like that, okay? So then the Midi board is putting out a 5-volt signal, but this requires 12 volts to work correctly. So this board takes the 5-volt signal from the Midi and steps it up to 12 volts using a UDN 2981 driver chip. 8 of those. I asked Roman, and he had it done that way already anyway, to eliminate any polyphony restriction on the Midi. So you can play as many notes as you want. And in all my experimentation, I've never had a Midi traffic jam. I've never had anything hang up or anything, so worked really well. So these have headers on this side, which then plug in to this board, like that, and then this board goes on the front, like that. Plug that in. Into an assembly like this. And then the front panel goes in front of all this, and machine screws hold it all together, and the front panel has plugs that plug on here. And that's what it takes to make this work truly, completely polyphonically, you know? No compromise. It's not fancy, there's not that much control over each individual note, but you have all the notes available all the time, which makes it different. It's like an old electronic organ or string machine, something like that. More an organ, I would say. So that's what this is. And as far as what it sounds like, here it is. I've got it going, well, you can't see in the shop. There's 2 Polk audio speakers up on the wall here. Not the ideal way to do it, but here you go. So in piano mode, which is my favorite, it's a little noisy. You got so much circuitry, so much signal in there floating around. I haven't been able to shut it all up. And if I turn it all the way up, you hear that whine. I've never been able to get rid of that completely. There's just so much in there, and if it proves to be a problem, I'll have to add a noise gate of some sort, but I think most people, it won't bother that much, and more on that later. But anyway, we can take the piano and turn the release time down. Or up. And have long release, which sounds good if you're doing something like this. And try to play the first line of this. That sounds nice like that. So you have piano mode where it dies out immediately, no matter what you do, or you have organ mode where the note stays on as long as you hold it. Release time works on that too, of course. And there is a vibrato, which is very difficult to engineer on this because, as I said, it's 12 individual oscillators doing their own thing, and the only way to round them all up is to change the power supply voltage going to them. And what I found is that when you lower the voltage, the pitch goes up, not down, as you would expect, I guess. The way it charges the capacitor has something to do with it. You have less voltage, so it's charging less every cycle, I guess. I don't know. But we can Vibrato speed and depth are individually adjustable, as you would expect. Every note is individually adjustable in the scale, C, C sharp, D, D sharp, and so on. So if you want to tune it in some weird temperament or screw it up all together and make the first 3 notes a triad of some chord and then the next 3 notes so that you could play chords by playing certain notes in different ways, have at it. You're free to do that. The holes in the front access the tuning trimmers through there. Midi in, Midi through. Master tune does not go very far because it's again changing the supply voltage to all 12 of the oscillators, and at a certain point they just don't want to stay together anymore. So large pitch changes you would have to retune. It goes back and forth maybe maybe 3/4 of a step, and to put it back. I found that the tuning stability of this is very good. Once it warms up, and you got to let it warm up for a good 10-12 minutes, it stabilizes and it stays rock solid. When it starts, it's sharp, and then it goes flatter until it reaches the point at which it was tuned. The CV inputs, as I said, I think they're a little bit of a disappointment, and I'm going to work on making them work better. You have to have the tone all the way down, and then you can hear that a little bit, but it's not that great an effect. Same thing with master tune. It doesn't do much yet. The thing is, I'm afraid of putting optocouplers in there. If somebody puts 10 volts in there as opposed to 5, how do I limit it so that you don't burn up the LED in the optocoupler, which is the only really good way to do this. I'm going to tweak that a little bit, but we'll get there. That's not a big deal. So in conclusion, the thing that is big about this is that, as I said, all the notes are available all the time. So if you want to do some really whacked out sequencing, you can. I've got a Roland here that I sequenced in a sequence of 2 measures where every step has about 20 or 25 notes in it constantly. And it's pretty bizarre sounding, but it shows what you can do that other ones can't do. Like a player piano, really. That's with release time all the way down. It takes on rhythm on its own. That's in piano mode. Which is really where it works better, and that's one thing I love turning that off because all the reverb tails are always perfect. Because every single note has its own capacitor handling the decay. It does it. There's no attack parameter. Those poor circuit mount, the surface mount boards, they're doing enough as it is. I can't engineer anything more in there with what I've got. to be able to do a variable attack parameter. And for me, the way I play, I'm used to organ stuff. That's why I like it. So that's it for now. I hope to do a better sound demo later with the sound going directly into the camera rather than through the camera's mics where you can hear all the ambient noise, because I don't think it really picks up quite how good it can sound on its own. So with that, I'll wrap it up.